one of the world's largest tire factories, where precision engineering meets mass production. This is where 300 components become a single tire. Every day, this facility produces over 18,000 tires through 25 distinct manufacturing steps. Let's follow one tire from raw materials to finished product. A modern tire contains over 200 individual parts. The process takes 15 minutes of vulcanization, but the journey starts much earlier. It begins with natural rubber harvested from trees in Southeast Asia. Each 35-kilogram bale will become part of dozens of tires. Synthetic rubber pellets add durability and heat resistance. Modern tires blend both natural and synthetic compounds for optimal performance. Carbon black powder reinforces the rubber, increasing strength by 600%. This fine material gives tires their characteristic black color. Precise chemical additives are measured to the gram. Sulfur enables vulcanization, while zinc oxide and accelerators control the curing process. High-tensile steel wire forms the tire's structural backbone. Each cord can withstand over 3,000 pounds of force without breaking. 9 polyester and nylon fabrics create the tire's flexible carcass. These technical textiles must be strong, yet allow the tire to flex with road variations. The Banbury mixer combines all ingredients under extreme conditions. This 800 horsepower machine is the heart of the compounding process. Inside at 160 degrees Celsius, counter-rotating rotors generate intense shear forces. The materials transform from separate ingredients into a homogeneous compound in just 4 minutes. The smoking hot compound drops onto water-cooled mills. Surface temperature exceeds 180 degrees Celsius, requiring careful handling. A 30-meter cooling conveyor gradually reduces the compound temperature from 160 to 60 degrees. Proper cooling prevents premature vulcanization. Each batch is labeled and stored in climate-controlled warehouses. The compound must age for 24 hours to achieve optimal processing characteristics. The extruder feeds compound through heated barrels reaching 100 degrees Celsius. This machine can process 2 tons of material per hour. Tread profiles emerge continuously from precision dies. Complex groove patterns are formed that will channel water and provide grip. The calendar coats textile fabric with thin rubber layers. 4 massive rollers apply tons of pressure to create perfectly uniform thickness. Steel cords are embedded in rubber at precise 1.2 millimeter spacing. These belts will resist the enormous forces generated at highway speeds. CNC cutting systems slice materials at programmed angles and dimensions. Every piece must meet tolerances within 1 millimeter. Components are staged for just-in-time delivery to assembly stations. This organized system ensures the right materials reach each building machine exactly when needed. The tire building drum is where everything comes together. This collapsible mechanism allows the tire to be built layer by layer, then removed when complete. First, an airtight inner liner is applied. This butyl rubber layer is what keeps your tire inflated for months without air loss. Textile carcass plies form the tire's foundation. Polyester cords run from bead to bead, creating the structure that carries vehicle weight. Steel bead wires anchor the tire to the wheel rim. Each bundle contains up to 60 individual high-tensile steel wires formed into a perfect circle. The carcass is turned up and over the bead wires. This critical operation creates the connection that will hold the tire on the rim under extreme forces. 2 steel belt layers are applied at opposite angles. This triangulated structure stabilizes the tread and prevents deformation at high speeds. A nylon cap ply wraps circumferentially over the belts. This layer prevents belt separation and enables safe operation above 200 kilometers per hour. Finally, the tread and sidewalls are applied. The tire is now complete but still soft and uncured, called a green tire. The green tire is carefully removed from the collapsed drum. It's flexible and weak at this stage, requiring vulcanization to gain its final properties. The tire is positioned in a preheated aluminum mold. An inflatable bladder inside will press the tire against the mold walls during curing. A 400-ton hydraulic press closes the mold under enormous force. Pressure reaches 15 bar, equivalent to 200 pounds per square inch. For 15 minutes at 170 degrees Celsius, vulcanization transforms the rubber. Sulfur creates molecular bridges, permanently linking polymer chains and giving the tire its strength. High-pressure steam supplies the heat energy for curing. The factory's boiler system provides steam to 24 presses simultaneously. When the cure cycle completes, the mold opens with a blast of steam. The tire has transformed from soft green rubber to a rigid, durable product. Ejector pins push the hot tire from the mold cavity. Still at 150 degrees Celsius, the tire is carefully handled by robotic grippers. 50 tires cool simultaneously on multi-tier racks. Temperature must drop below 80 degrees before quality inspection can begin. Every tire undergoes visual inspection under bright lighting. Trained inspectors check for surface defects, incomplete mold fill, and marking legibility. Laser scanners measure dozens of dimensions simultaneously. Tread width, overall diameter, and bead spacing must match specifications within half a millimeter. X-ray imaging reveals the tire's internal structure. Steel belts, textile plies, and bead wires are all verified without damaging the tire. Dynamic balancing detects mass irregularities. Even 40 grams of imbalance would cause vibration and premature wear at highway speeds. The uniformity machine measures stiffness variations around the tire's circumference. Excessive variation would create ride discomfort and uneven wear. Proof pressure testing inflates tires to 4 times normal pressure. This destructive test on sample tires verifies structural integrity of the entire production batch. Submerged underwater at high pressure, any leak appears as bubbles. Perfect air retention is essential for safety and fuel efficiency. Ultrasonic testing detects internal flaws invisible to the eye. Sound waves reveal delaminations or voids between layers before the tire ever reaches a customer. Real-world testing begins on wet handling tracks. Vehicles equipped with test tires navigate flooded curves at increasing speeds. Aquaplaning resistance is measured in deep water channels. The speed at which the tire loses contact with the road surface is a critical safety metric. High-speed endurance testing simulates 4 hours at 270 kilometers per hour. Tire temperature reaches 110 degrees Celsius, validating the speed rating. Rolling resistance directly affects fuel consumption. Lower resistance means better fuel economy, measured precisely on specialized equipment for EU labeling requirements. Accelerated wear testing predicts tread life. Standardized abrasion tests determine if the tire will last 60,000 kilometers or more. Impact testing simulates pothole strikes and curb impacts. The tire must withstand 450 joules of energy without puncture or structural damage. Noise testing measures exterior and interior sound levels. European regulations limit tire noise to protect public health in urban areas. Machine vision AI grades every tire automatically. Cosmetic defects are identified and tires are sorted into quality tiers before labeling. Laser marking etches the DOT identification code permanently into the sidewall. This code tracks manufacturing date and plant location for regulatory compliance. Barcode labels enable complete traceability through the supply chain. Every tire can be tracked from production batch to final customer. Robotic systems stack tires with millimeter precision. The factory achieves 120 tires per hour throughput with zero damage to finished products. Stretch wrapping protects pallets for shipment. 6 layers of plastic film create weatherproof packaging for global distribution. A 30-meter-tall automated warehouse stores over 10,000 pallets. Computer-controlled cranes retrieve specific tires in seconds without human intervention. Quality documentation links every test result to individual tire serial numbers. This traceability system enables rapid response if any quality issue is discovered. Loading docks ship 500 tires per trailer to distribution networks. Each truck carries precisely matched sets organized by size and specification. The factory produces 18,000 tires daily with 99.2% quality pass rate. Real-time monitoring ensures consistent output across all 6 production lines. This single facility is just one of hundreds worldwide. The global tire industry produces 1.8 billion tires annually to keep the world moving. From racetracks to highways, from trucks to bicycles, tires engineered here perform in every environment. Months of testing ensure years of reliable service. Each tire represents 15 minutes of vulcanization, but a journey through 25 manufacturing steps. Over 200 components working in perfect harmony. Production never stops. 3 shifts operate 24 hours a day, 7 days a week. The factory floor is always in motion. From molten rubber to precision-engineered product, this is modern manufacturing at its finest. This is how a tire is made.